Island escape. You drop onto an island, starting at the very middle of an end by end terrain. Luckily, you have a raft and a map showing the elevation of each square plot of land. The ocean at elevation 0 surrounds the island and lies all along the borders of the map. You can move directly north, south, east, or west to an adjacent plot, provided the difference in elevation is at most 1. Larger differences indicate steep terrain which cannot be transferred carrying your raft. Determine yes or no if it's possible to reach the ocean and get away. Input line 1. An odd integer n for the size of the map. Next, n lines. Space separated integers for the elevation of each plot, of which there are n in the row. Output line 1 yes if the ocean is reachable, otherwise no. Constraints 2 less than n is less than 20. N is odd. 0 less than or equal to elevation is less than 10. This is the example for input and output. These are the test cases. I will solve this puzzle in C++, and at the end, I will explain how I did it. Okay, time to explain this code. This code works with a grid of numbers, kind of like a little map or matrix. The goal is to start in the center of that grid and try to reach any cell that has the value 0. But there's a rule. You can only move to neighboring cells if the difference between their values is 1 or less. If you can reach a cell with a 0, the program prints yes. If not, it prints no. At the top, we have a small structure called cell. This just represents one square in the grid. Each cell has a number, which we call val, and a flag called visited, which tells us whether we've already checked that cell or not. At the start, every cell's value is 0 and visited is false. Then there's another structure called point. A point simply represents a position in the grid with two coordinates, x and y. You can think of them as the row and column. There's also a small helper function that lets us add 2 points together. This is handy for moving around the grid. For example, if you're at position 3, 2 and you move down by 1, you'll just add 1, 0 to get 4, 2. It makes the movement logic much cleaner and easier to read. Next, we have a class called grid. This class is basically a wrapper around a two-dimensional vector of cells. When we create a grid, we give it a size n, and it automatically creates an n by n grid filled with default cells. Inside the class, there are some small helper functions. The add function lets us access a cell by its coordinates safely. There's also an overloaded operator, so we can access rows easily, and a couple of functions that let us use range based for loops. These make it easier to loop through every cell without writing complicated nested loops later. In the main function, we start by defining 4 directions we can move in: right, left, up, and down. These are stored as points, so 10 means moving one step down, 01 means moving right, and so on. Then the program reads an integer n from the input, that's the size of the grid. After that, it creates a grid of that size and then reads in all the numbers that fill each cell. Once that's done, our grid is ready to use. Now we pick a starting position. The rule says we start from the middle of the grid. So we calculate that as n divided by 2, n divided by 2. We also create a dequeue, which is like a flexible list, and use it to store positions that we still need to visit. We add the starting point, the center of the grid, into that dequeue first. Now comes the main search loop. While there are still positions to visit, we take the first one from the dequeue. That becomes a current position. We grab the cell at that position and we mark it as visited so we don't come back to it again later. If that cell's value is 0, that means we reach our goal. So we break out of the loop because we found a path to a 0. If it's not 0, we look in all 4 directions: up, down, left, and right. For each direction, we calculate what the next position would be. If that position goes outside the grid boundaries, we skip it. If we already visited that cell, we skip it. And if the difference between the current sales value and the next sales value is greater than 1, we skip a 2. Because the rule says we can only move if the difference is at most 1. But if the next cell passes all those checks, we add it to the DQ, meaning we'll visit it later. This process continues. We keep checking cells and adding valid neighboring ones until either we find a 0 or we run out of positions to check. If we find a 0, we break out early. If the DQ becomes empty, it means we've explored everything we could but never found a 0. At the end, the program checks if the last cell we looked at had the value 0. If it did, we print yes. Otherwise, we print no. And that's how I did it.